Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve a shaft with surface traction force. I have taken a shaft of diameter 50 mm and length of 200 mm. This is our geometry. Loading condition is we are going to fix the right side surface, and here we are going to apply the surface force of 500 Newton. And we have taken a material of steel with the Young's modulus of 210 gigapascal and Poisson ratio is 0.3 and density is 7860 kilogram per meter cube. This is actually a calculus tutorial I have taken. Now here you can see Prepromax tutorial. So surface traction load of minus 500 Newton. They are saying that analytical result is 8.17 megapascal. Now we will compare the result with analytic. Okay. So now we just go to open the code aster. So I'm just opening salome meca. Go to geometry. Now we need to create a cylinder, the shaft of circular rod. We'll take the first option, base point is O, vector we can make it X, and radius they have specified as, just go here, the diameter they specified. Now we'll convert this diameter into meter, actually divided by 1000 you make it 0.05 meter is the diameter. So radius is 0.025. Just go to salome meca. The radius is 0.025 and height is nothing but length 200 mm they are saying, that means 0.2 meter. Just apply and close. Go to fit screen. So this is our model. Now we have created our geometry. It's very simple geometry. Now we'll create groups to apply the boundary conditions. Go to new entity, groups, create groups, surface group. Now we'll fix the left side surface. This is, I'm just naming as fix. Any name we can give. To easy understand, I'm giving fix. Here load I'm just giving. So apply and close. Now I have done creating geometry and creating groups. Now we'll save this file. Just navigate the files where you want to save. I just want to save it in the picture folder. So this is the shaft with surface traction. I'm just already as study 1 is there. I'm just giving another name, study 2. Now we'll go to mesh module. Now we are in the mesh module. Just select the cylinder one, go to mesh, create mesh. Now we can directly choose NetGen 1D, 2D, 3D. Use simple parameters. So 0.003 I'm giving. Save OK, apply and close. Right click, compute. I'm giving 3 mm is the element size. It will generate 3 mm element size with the mesh. So now we have created a very fine mesh. So now we have done creating the mesh, and check the groups also. We have two groups. One is the fix, another one is load. Now we'll save this file. Now we'll move into aster study to create the setup. Just move into aster study. This is actually a simple case. We can generate the command file using a wizard. From that we can edit based on our case. So now we are in aster study. I'm going to use a wizard, add a stage with the assistant. That means wizard to create the setup. So just dummy setup I'm going to create. I'm just leaving everything. One side I just want to fix it. Next, other side I just want to apply a pressure load. Just one I'm giving. I'm just giving a name and where to want to save. So already result file is there. I'm just giving some other name, result 1.rmed This is the extension for post-processing. Finish it. Now we have created the setup. See, we have read the mesh, we have defined the model. This is the 3D mechanic model. We have defined the material and we have assigned the material. Now we'll check the material. So material is 210 gigapascal only and Poisson ratio is 0.3. Density is not required for steady state analysis. I mean static analysis. So we have two groups. One is meca BC and meca charge. Meca BC is the fixed boundary condition. We need not to change it. Here you can see it. Meca charge is the loading condition. So now we need to apply as a surface load. Just untick this pressure reference. There is an option called force phase. Choose it. So in pressure reference and force phase, both it will take as a pressure load only. As in our case, they have given a 500 Newton as a force. Now we need to convert that into as a pressure. Then we need to apply it. So force by area we need to do it. So in which direction is Z direction? So Z direction, here we need to change into variable, add a variable. So whatever the value they have given is, we need to make it small conversion, because the code aster, every force, pressure both apply as a pressure. It's a pressure command. So only thing is pressure, only positive and negative value, compression and tension only we can do. But in the force space, we can give the direction, only the difference. But everything, it will be a pressure loading condition, pressure load command. So now we have the value of force that has to be converted to as a pressure to apply it. So make it force. They have given 500 minus 500 divided by area. So this is a circular area. So pi is in pi by 4. Or pi into d square. So d is a 50, 0.05 divided by 4, close bracket. Now see, pi into d square divided by 4. This also you make it one more bracket. So up to making proper command only, it will show without any error. So pi into d square divided by 4, whole bracket I have made. So this divided by this value. So this is the value. Just apply it. Just close it. It is applying in negative direction. Now we have specified the value. Whatever the value they have given is, now we have converted that value into our code aster values and we have applied. The only thing is, there is no force command for in code aster. Only the pressure command is there. So, and result. Now just say OK actually. So the detail. No, not respect the rules. It asking to specify the groups. So load group. Just say OK. Just say OK. Just apply it. Say OK. So now we have see in load, in FEZ we are applying the force value. The force we have converted into the variable. Now we just go to result. We are calculating steady state analysis. Both we have. Just apply and say OK. Now what it will do, it will only calculate the primary variable of displacement. To calculate the, to view the results of stress, everything, go to calchamp. Same name you just give it, result. In constraint, here we can calculate sigma value. And criteria, here we can calculate equivalent stresses, equivalent element and equivalent node, model and material. Just apply it, save OK. Now we have done of calculating stresses, everything. Now just go to output. We need to view the results. So instead of meca static, choose calchamp mesh. Here there is an option called tut-champ S. Tut-champ is nothing but all the values whatever we are calculating in calchamp, save the result in output format. That is the value. Instead of going this one, we can go for namcham also. Only thing is we need to independently or specifically we need to specify it. Okay. So just go to OK, just apply it and save OK. Now we have done everything. Just save this file. Now we can go for solving. Just click this plus button, make this auto reference into 5 seconds. Just apply it. If you want to increase the memory size, we can increase and we can run it. First, what it will do, it will export the values. Just go to the folder here. So it will generate the study file, run case, stage 1. It will export the med form file, that means mesh file and command file. From that it will read both and it will run. After running it, so the solving is done without any error. This is the message file we are viewing. We can go for message also. So the same message file you can see it here. So this is the file we are viewing here. So now we have done of solving without any error. Go to post processing using paraview. Now we need to compare the result. Code aster 42. Here the result one RMD is our result file. Just apply it. Now we'll see the displacement first. And so this is the displacement value. This is very minimum. Any direction that is the magnitude value. If you want to go for dz, that is the maximum value. It will go in the negative. Minus 2.1 is the maximum value because it's bending. To view the deformed shape, go to wrap by vector, give some scale factor, just apply it. Now see, this is the way it's getting bending. And you want to see the animation, just click it here, create a new animation track, just OK it. Now we can animate it. So this is the way it's going to bend. To make it loop, we can loop it. So this is for post processing to view the result, and the way how we are applied the load, the same way it's animating. So it's correct. Now what we can check the results. 1Me sisters. Go to SIEQ node. There is an option called VMIS. This is nothing but 1Me sisters. So the maximum 1Me sisters where it coming, we can view it. Now they are saying 8.17 megapascal is the maximum 1Me sisters. Now we can check it here also. So now we are getting 7.4 megapascal. That is because we have taken only a linear element. To make mesh finer and convert that element into quadratic, we can get accurate result to the analytic. So this is the way we can compare. Now we are getting 7.4. Just convert our element into quadratic, we'll get very close value to the analytical results. So to view different colors, example, I just want to see it in blue to red rainbow. Just apply and close, and here we can change this into 12. So this is the way most of the software will show the results. And this is, now we can make that wrap by vector also. We can give some scale factor. We can view the results like this also. So thank you. So this is the way we can do the post processing, and we can show the result to our customer. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.